Hey everybody, it's Mr. Oaks. Today what we're going to talk about is sketching functions from verbal descriptions. And really what that means is I'm giving a situation, it's written out in words, I draw a graph to go along with it. And the good thing with sketching a graph is that I don't have to get very specific, meaning I'm not stuck with going with specific numbers. It's not like, well, at this point it has to be, I have to go to 3 comma 50, or at this point I have to be at -2 comma 7. It's not what we're looking at. We're looking at how can I just, when someone's describing something, uh, how can we sketch it out to kind of get an idea of what this relationship looks like. Okay, and my sketch could look different from another person's sketch, could look different from another person's sketch, but we're all sketching the same thing and it should look similar. That's what's most important. It should look similar. So the first thing we're going to look at is a description of a linear function. A linear function. Now, when I say that I don't necessarily have to have exact numbers, that doesn't mean we won't necessarily use numbers, and I'm just going to apparently keep saying the word necessarily. I don't know why that's happening. But in some of these sketches, we will have numbers. It's just that we're going to kind of use them as like a reference point. So I have this problem here. Janet is at the top of the hill, of a 50-foot hill. She slowly walks down the hill till she gets to the bottom. It's kind of vague. The only real information we have is the hill's 50 feet tall and she's gonna walk down it. We're gonna assume that it's probably at a constant rate. The first thing I have to figure out is, well, what are the variables that we're dealing with here? One of them is definitely the height of the hill. Okay, so I'm going to write the height of the hill. I'm going to say the height is going to be affected by something, and we'll be able to figure out what that is in a second. But the height usually is affected by something, and that something is usually time. Time, 99% of the time, is going to be our x variable, our independent variable. So what I can do is I can write, I'm going to put, that's our x-axis, that's our y-axis. Okay. Along my x-axis, I'm just going to write the word time. Now, it doesn't say how long it takes her to walk down this hill. It's a 50-foot hill, so it's probably not that steep, but it also says she's walking slowly, so maybe it only took some seconds, maybe it took some minutes, maybe she's walking real slow and somehow 50 feet takes her an hour. We don't know. All we know is she's walking down the hill slowly. So along the bottom we have time. I can't put numbers. I can't even really put a label at this point, I don't really know. What I do know is the height of the hill. All right? So I could kind of write height over here. I'm going to have to go this way because I can't write otherwise. Height. And I know two things about height. I know that we're measuring it in feet, and I know one other piece of information. I know the height of the hill. So I know where she's starting at. She's starting at 50 feet high. 50 feet high. I can't really put any other information. I mean, I could put 0, 10, 20, 30, 40, and then 50, but I don't really have it. All I really know is she's starting at 50 feet and then she's slowly walking down to the bottom of the hill. So I'll start up here at 50 and then I'll draw a line relatively going like that. And that's it. That's my sketch of this situation. Janet started at the top of a 50-foot hill and then she slowly walked down it till she got to the bottom. That's it. Here's her height. Here's the amount of time. That's it. We really don't have much else we can do. That was weird. Alright, a little glitch there. Now, sketching a linear function, it's not too bad. You know, you either are drawing it so that it's decreasing going from left to right, increasing while going from left to right, or it's just constant. It's just going straight across. The big thing is when we come across a function that is nonlinear. Now, there are a number of ways a function could be nonlinear. It might be that you have it kind of breaking up at different points. It might be that it curves because of certain things. So like if I was describing, you know, John was throwing the ball to his friend, and what is the path of the ball? Well, he might throw it up and it'll go up in the air and then it'll come down over time. Well, maybe we know how far away the friend is, maybe we don't, maybe we know the amount of the time, you know, so depending on how that's written, we would set up our graph using the information. And that's one of the things we always want to do. You'll notice in both of these examples, I start off with a graph that has no labels and no markings on the axes whatsoever. Because they're, you know, we're not going to have very specific information to make our graphs exact. You know, we're sketching it. We're getting a kind of an idea. Okay? Things I do know, this is my x-axis, this is my y-axis. So I look here. This is a long one. We got Franklin decides to ride his bike from his house to his friend's cabin, which is 2 hours away. He stops after 45 minutes to eat lunch for a half hour, then he continues. Sketch a graph showing the relationship between his distance from home and time. So in this case, we're kind of told what our variables are. Distance from home and time. So I know that, again, 99% of the time is going to be my x variable. So I'm going to write time along the bottom. And again, I could write minutes, I could write hours. I'm not really marking anything off. I'm not making lines along my x-axis. So as long as I have time there, I'm kind of good. It doesn't mean I can't write, time in minutes to kind of get a little bit more specific, but it's really not necessary. Distance from home. So that's going to be distance from home. That's going to be our y-axis. That's going to be our dependent variable. This I can kind of get away with writing like a label, in the sense that he's going to be riding for 2 hours and he's riding his bike. It's probably going to be miles. So I'm going to write miles. I feel confident that that is okay to write. All right, dead space over here. I'm going to go back over here. Okay. So what I'm going to do is I'm going to use this. I'm going to go, okay, what information do I have? He's riding his bike from his house. Well, if my y value is the distance from the house, then my guess is 0 is starting at the house. So I'm going to start here. I'm going to start at the origin. He's going to ride his bike. He's going to ride it for 45 minutes before he stops. So he's going to ride it for 45 minutes, probably at a constant rate. All right. And then he's going to stop and he's going to eat lunch for a half hour. So, I mean, if I'm saying that's 45 minutes, then that's probably about a half hour. And then he continues on his way. So I've got 45 minutes, that's half an hour. I need about another 45 minutes, so I'm going to continue like that. And there we go. That's our graph. Okay? And maybe this is the 2 hours, maybe this isn't, you know, maybe it's going to take a little bit longer, maybe he's driving a little faster, riding his bike a little faster. I don't know. I don't necessarily have to put an arrow, I can just leave it as is. And if I'm looking at this graph, what I can say is, well, where it's increasing, he's riding his bike at a constant rate. This section where it's flat, that's where he's eating. He's not going anywhere. His distance from home is not changing over that time. But then he gets back on the bike and starts riding again, so the distance is again increasing. And that's basically it. That's how we sketch a graph. Again, someone else could sketch this graph and their lines could be angled differently from mine. The length of their lines could be longer or as I do the exact opposite of what I'm about to say, longer or shorter. Sketching doesn't have to be exact. If you're sketching your graph and your teacher looks at it and they look at yours and they say that's a good job, and then they look at your friend and your friend has a graph that, yeah, it looks similar, but their lines are longer, their angles are different. As long as it can match up pretty close to what is being described verbally, then your sketch is good. I hope this helps. I know that sketching can be a little bit confusing sometimes, but really it's just give an idea of what is being described to you verbally, what's being described in the problem, and you'll have it down. As always, I hope this was helpful. Please like and subscribe. Comment, let me know if there's anything specific that you would like me to go over, and I'll do my best to do it for you and explain it as best I can. I'm Mr. Oaks. Please keep on learning. You only get better. Have a good one.